Hello, I'm Chuck Martin, and this is the Voices of the Internet of Things. With me today is Daniel Betts, CEO and founder of Blue Frontier. Daniel has been president of EnerFuel, CEO and founder of B Power Tech, and director of innovation at Front End Analytics. At Blue Frontier, Daniel is focused on developing ultra-efficient air conditioning. Welcome, Daniel.
Oh, it's such a pleasure to be here.
So, why air conditioning? You've been doing air conditioning for a long time.
Yeah, actually, so air conditioning ended up becoming my the second half of my career. So I started first in advanced power generation technology development. So I ended up working first on like hydrogen and fuel cells and even on battery technology in automotive, residential buildings, and then grid level applications. And air conditioning ended up becoming more and more important to me um, because I realized that I was, that, the more power you produce, um, you realize that that power is going towards um, air conditioning, which is this very annoying load that is growing very, very fast. And what's happening is as the planet warms and also as the world becomes more affluent, air conditioning becomes one of the main things that people end up acquiring, either for themselves or expecting it in the places that they work, in the places that they shop, in the supermarkets that they go to, right? They prefer the supermarket rather than a sweltering outside market. And so
Says the
we
true Florida resident.
Right, right. Absolutely, absolutely. I mean, if you think about it, I mean, the entire you know, the entire economy of Florida would not exist um, if it weren't for the advent of highly accessible air conditioning, which first enabled people to work in factories and in packing places and in agricultural, locations, um, that enabled people to have a place to go that allowed them to escape the weather and basically live inside buildings that provided them with almost perfect weather year round,
So
regardless
what's
of
wrong
what's
with
going on
so what
outside.
what's wrong with air conditioning now? I mean,
So
Florida's air conditioned.
yeah, absolutely. Florida is an air-conditioned place, and in fact, the entire world is moving towards becoming an air-conditioned world. And and uh, and so, if I live in the world of power generation, you realize that unless like you can start producing more and more power, but that power is being consumed by air conditioning, and the time that everybody consumes air conditioning is all at the same time at the moments when it's hottest outside, which means that everything has to be sized for the air conditioning load because that's the biggest load that occurs all at the same time. And so if you look at the grid, the electric grid, which is the way that we all get power, it is completely designed around the peak design day, which is the hottest day of the year, where at the moment where everybody's going to turn on their air conditioner. And so the infrastructure of everything is priced to that worst event. The size of everything, all the infrastructure, all the cables, all the things that we have to buy are designed to be able to cover air conditioning. And that makes everything way more expensive than it has to be. If you're planning for the extremes, if you have to size everything from the extremes, but your averages are way below the extremes, then you are overpaying. And so the idea is it possible in my head to eliminate this peak load and reduce it? And in that reduction, make it more accessible to everyone without affecting its impact on the environment. So because air conditioners are consuming power in a very, concentrated period of time, not only do they affect the infrastructure, but that infrastructure that goes with air conditioning, most of the time is non-renewable. So non-renewable energy, and renewable energy has environmental benefits, of course, but also it is a technology that allows anybody to produce power no matter what without needing any other resource except for the sun or the wind wherever they are. And everybody has access to sun and wind, and so therefore it allows for sort of a democratization of access to power, except that that sun and that wind only blow or only come out during a very short period of time, which does not match when the majority of air conditioning is being used, which happens to be in the late afternoon and into the early night.
So what is it you created? A better air conditioner?
We created a much better air conditioner. So the aha moment was to realize that the conventional technology of air conditioning was invented over 150 years ago. We kept with it, but it is not designed to be flexible in terms of being able to consume power at a different time than when you need to get air conditioning. And enable so meaning that the energy storage for air conditioning is being externalized from the air conditioner into battery systems that go in the grid. Those battery systems are a booming market around the entire world and in the United States. And also, air conditioning actually that we have today actually um, is a device that is not really designed to give you the level of comfort that you would want to have. So let me explain. Air has two components. They have has the air within it, so oxygen and nitrogen, um, but it also has water in it. And the way that you keep yourself comfortable is by the, exchanging heat with the environment. Well, it turns out that that heat can be transferred either by the temperature difference between your skin and the environment, but also by evaporating water from your skin. And that evaporation of water from your skin actually is way more effective at transferring that heat from your body to the environment. In fact, it's one of the superpowers of human beings.
So today's air conditioners, don't they also take out the water? Take out, so that's why they lower humidity?
They lower humidity, but in an indirect, very energy intensive manner. So what they do is that they have to overcool the air to bring it down to a temperature where it condenses out of the water condenses out of the air. And so you need to, so that's why when you walk into a building, here in Florida in particular, you walk into a building, it's humid outside, so the building is trying to dehumidify, and therefore the building has to provide is operating at a temperature that is around 65 degrees Fahrenheit. You walk into the building, you're freezing, and you say, why are they putting the air conditioning so cold? Why? It's because they're trying to control for humidity inside the building. If they allow the humidity to rise, you will start sweating, and in that sweat, it won't evaporate into the environment, so you'll start feeling clammy and uncomfortable. And also, you'll end up having condensation of water in places that you don't want it, in your vents, it will be absorbed by different materials that you may have in your, and you will
So
start creating mold.
so what is it you figured out that's the magic bullet here?
Okay, so the first thing that we figured out was that instead of using having to drop the temperature of air to condense the water out of it, which is takes an enormous amount of energy, we could do it by using what is called which is a materials called desiccants. Um, Desiccants are the thing that you have in your protein shake, right? These are these materials that if they come in contact with air, they will absorb the humidity right out of the air.
Sponge.
And ah,
Like a sponge.
like a sponge, absolutely. But we've developed a material that will do that, but it's a liquid, which means that it can be conveyed. And not only that, it's a liquid that has no corrosion, doesn't create corrosion. So salts typically are materials, liquids that salt solutions are liquids that would absorb humidity out of the air. However, if you put them in contact with metals, they start rusting the metal, right? And so that's corrosion, and therefore you cannot really use them because if you have a spill, you don't want to start corroding your building. So
Were
we
you
created
one
a
so
liquid
one day
desiccant.
did you say we need to find something that will absorb this the water? I mean, how did that come about?
I was looking for a solution to the air conditioning peak power problem. an energy consumption problem because I was annoyed at air conditioning because I was like, I'm working on power generation and every project is being sized by air conditioning. We gotta get rid of it. And I ended up giving a talk at the National Renewable Energy Labs. Actually, they just changed the names to the National Lab of the Rockies, NLR. I got to accustom myself to the new name. But um, the there was a I was giving a talk there, and I was showcasing how for um, for the U.S. Department of Defense in the Iraq War and in the Afghanistan War, forward operating bases were providing convoys of fuel to the service, to the warfighters and to soldiers. And if you look at how that fuel was being used, an enormous portion of it, actually a majority of it, was being used to provide air conditioning. And then if you look at where were the troops most vulnerable, it wasn't a convoy of fuel, right? So we were, in fact, putting at risks American service people's lives in order to be able to have air conditioning. And if we could eliminate or dramatically reduce the energy consumption of air conditioning, we would save lives um, in the battlefield, but we would also save lives here, right here at home, because in the in the last 10 years, extreme heat has become the deadliest type of weather in the United States, weather event in the United States. And so
So over the you've been watching air conditioning for a long time. Has air conditioning changed until before this, or has it stayed basically the same for the last 100 years?
the physical phenomena associated with air conditioning has stayed the same for 150 years. There have been improvements in some of the components, better compression, different refrigerants, to avoid toxicity and ozone depletion, things like that. But in but in the but the air conditioner as a physical phenomena of using vapor compression, which is the way that we create cold and hot inside our by compressing and expanding these refrigerants, is exactly the same. And therefore there's a limit, a physical limit of the efficiency that you will ever be able to get out of it, and there's a physical limit in its operating envelope that you will ever be able to get out of these devices, right? Because they are
Yours use
bound by
refrigerant as
thermodynamics.
well or not?
I use a very small amount of refrigerant in our unit, but I'm using it in a very different way. I'm not using the refrigerant to create air conditioning. I'm using the refrigerant to change the concentration of the salt solutions that I've been talking about, from a low concentration point to a high concentration point. That concentration difference is created by evaporating water from the salt solution. So that evaporation of water turns out to be the energy that I'm building up inside the salt solution, because once you evaporate that water from it, you create a salt solution that is ready to pounce, absorbing water from the atmosphere. And I utilize in our air conditioner that potential energy of absorption of water to drive the humidification, and then also create the conditions inside this specialized heat exchanger to evaporate water on alternative channels, which also ends up dropping the temperature of the air going into the space. So you
Oh,
end
so,
up with
so
low temperature, low humidity air into the building.
so if a company is using your air conditioner, you do sell these now, right?
Yes, exactly.
Okay. So if they're using that and they had the old-fashioned air conditioner before, would the air and the temperature in the building and everything feel the same as it did before?
So I can do that, and that would be fine. But I think it would be stupid to keep it the same, because the truth is, modern air conditioners don't really keep us that comfortable. In most cases, we have to take sweaters around. Here in Florida, in the summer, everybody wears a sweater. Um, and that's because the humidity is varying, and also we have to keep the temperatures very, very low inside spaces. So they're not really doing a good job of keeping people comfortable. We have the opportunity with these types of technologies to control humidity and temperature independent of each other, So I can give you a low humidity space without having to crank the temperature down. And I can also um, give you low temperature without having to give you such low humidities. And so the combination of those, so that gives a separate, gives you two dimensions of controllability to give people a wider range of operating envelopes where they can be comfortable, and also um, expand and adapt the air conditioner operation to the actual use case of a building. So if there's a lot of activity in the building, you want to have lower humidity, lower temperatures. When the activity is reduced, you may want to increase the temperature a little bit because there's no one there. Um, if you have a building, and we're doing, for example, classrooms where the classroom is not unoccupied, you still need to ventilate, bring the humidity low, keep the humidity low, but there's no point in keeping that classroom at 65 degrees Fahrenheit, right? So you can bring the temperature up to around 75 to 78. No one's in there, but you're still ventilating and keeping the humidity low in the classroom, preventing mold or insalubrious conditions there. That's something that we can do that conventional air conditioners just would never be able to do.
Companies understand this when you talk to them?
People that are in the industry understand the potential of doing things like this, but given that it doesn't exist, in the normal things that people buy, it is a value stream that is created after people buy our units. So most people buy our units because they need air conditioning and they're expecting it to do exactly the same thing that the conventional air conditioner will do. And then once installed, we then start showcasing capabilities that go well beyond, by utilizing optimizations for the actual building use case. And then people really do realize that things have changed in a dramatic manner. So we have many cases in which we have installed units and the people inside the building have immediately noticed people that, and they and they let us know that, wow, like, what have you guys done? In fact, one of one of the my favorite installations, one of the first installations, was with Waffle House, which in which we installed our unit, and when we turned on our unit for the first time, um, some of the people that worked in the in the Waffle House came out to try and, curious about what we were doing, and our service people were a little bit nervous because, this was one of the first units that we had ever installed and we had turned it on. And it's like, hey, is everything okay? Are there, noises or smells or anything that coming from our air conditioners? Are you guys okay? And the comment was, "Oh my God, no, it's more than okay. It's been a long time since we haven't stopped sweating in the kitchen because the kitchen
Is
is
that
hot
because
and
you
humid."
lowered humidity more?
Because we immediately created a lowering of humidity in the space, and we were able to keep the humidity low even on the worst days of the summer. And so that changes completely the way that that restaurant is felt by its customers, but also by the people working in it.
Don't people traditionally not understand that air conditioning is really about humidity and comfort is really about humidity, not temperature?
Most people don't understand that, and for good reason, because we've been trained by having a thermostat that only gives you a temperature range.
Right.
Very advanced thermostats sometimes give you a humidity point, but that humidity point comes at the problem of giving you over, cold spaces that are overly cold. But we've been trained for that because the industry doesn't really have a solution for you. And so just control by temperature. And you will notice that your temperature range that you feel comfortable inside your building or inside your home varies on the season or the time of day. So sometimes when you're going into bed into the afternoon, the thermostat it was at 70, 78 or 76 in the middle of the day. You were okay. Into the early afternoon, you're like, why it's so hot here? And you're dropping down the temperature of the thermostat. Why is that happening? It's because the humidity is changing inside the space, and it's changing your perception of temperature, and it's an overwhelming thing. And therefore you think that you need to change the thermostat. And that thermostat setting is like going up and down, trying to chase the amount of clothing you have and the amount of humidity that you're experiencing inside your house or
But
inside your.
your air conditioning unit, is it mainly for buildings, for big buildings or industrial, like or restaurants or that sort of thing, or is it
Yeah,
something different?
yeah, we're starting in the commercial building space. These are restaurants, supermarkets, municipal buildings, schools, universities, churches. Yeah, the gamut of commercial buildings.
And I've seen your unit, but I'm not familiar with commercial units. Is it roughly the same size as other traditional units?
It's a little bit larger than a conventional unit in the way that we've packaged it now. And that's because we're embedded into each one of our units, uh, the, you know, in and the energy storage component. And so the each one of our units are able to provide cooling with almost no electricity consumption from 4 to 6 hours. Um, um, and it's an inherent thing within the unit. And then if you need resiliency, we have done work in which we are able to extend that 4 to 6 hours. Like let's say you get hit by a hurricane or you have a blackout, we can adapt the unit's controls to give you even extended air conditioning runs. So we did a project in which we were able to do 60 hours of air conditioning and office space on a simulation of a hurricane here in Florida with that same energy storage that we had embedded originally.
For your system, does it bring down humidity faster than a traditional old-fashioned air conditioner?
Yeah, it will so in fact our unit first dehumidifies and then cools. So it's going through a process of dehumidification internal to the heat exchanger. Dehumidification takes precedence and then temperature reduction is secondary.
So is the effect essentially that an old air conditioner, say in a building, people would set it at 76, and then with your air conditioner, they might set it at 78, and they feel the same? Is that sort of thing?
Yeah, exactly. That's exactly what would happen. And the interesting thing is that if you set it, even if you set it at 78, two people will experience comfort in a wider band if the humidity is low of temperatures than if you have a high humidity level, two people will experience the same temperature drastically differently. And you see that in like we go to Arizona or to Colorado or Las Vegas, and everybody's like walking around, and everybody feels okay being outside in 90, 92 degree heat because they're like, yeah, but it's dry heat, right? And it's a wide range of people that are feeling okay at 90 degrees. But if you're in Miami and it's 82 degrees, you're dying, right? Because and everybody's uncomfortable. There might be one or two people that are like, yeah, I've been accustomed to this and it's okay, but the majority of the people are experiencing you know heat stress at
Because
this
of
point.
this new technology, do you think that places like London, for example, where there's not a lot of air conditioning, that all of a sudden that they can look at this kind of technology and say, hey, now we can have some efficient air conditioning without the I presume your operating cost is lower?
Yeah, operating cost is much lower. Yeah.
Yeah, so that they can say, hey, maybe we should put in air conditioning now because it's more cost effective. Like some markets where AC is just not a big deal. Do you see that happening over a long period of time?
Yeah, absolutely. AC is moving from becoming a luxury to becoming a necessity. Actually, Europe, and in fact, Northern Europe is one of the fastest growing air conditioning markets in the world. Um, and Europe is the fastest, the continent with the fastest increasing temperature of all the other continents where we inhabit. So yeah, there is a need for air conditioning in those places, and in fact they have it in every commercial building, and so it's already there. um, it's expected, but it's going to increase, and so accessibility, like you said, is essential. So one of the things that we see is that one of the reasons why people don't have access to air conditioning is, one, its capital cost is high, and second, its operating cost is high because it uses an enormous amount of electricity, preventing people to have access to good air conditioning. So they end up either not having it at all or having buying something that is super inefficient, that use it sporadically, just trying to figure it out, how to survive periods of heat stress. And in fact, lack of air conditioning access it's a source of poverty because lack of air conditioning access represents loss of productivity, loss of preservation of your goods and the products that you have and the produce that you have, etc. And also it leads to insalubrious conditions. And so we want everybody to be able to have air conditioning. The planet is warming, and so that access only occurs with two things. One, drop the capital cost of being able to acquire air conditioning, and then second, make air conditioning electricity consumption low so that the operating cost of it is very low. So we do that, or we're trying to do that, I should say, with Blue Frontiers and Blue Frontiers technology. Number one, we drop the energy consumption of the unit, making it such that now you're paying, less than half of what you were paying before. Sorry, more than half of what you were paying before. And in some cases, you can go 80% reductions in the entire cost of electricity associated with the air conditioner. But second, the air conditioner has energy storage. So it can become um, part of the infrastructure of the grid to balance itself out and displace batteries that would have to be put on the grid in order to maintain reliable power production and also to maintain the cost of the infrastructure low and also meet future needs for energy that are coming from other sectors like data centers and electric vehicles and others. If that were to happen, air conditioning could be rate based, which means that the utility might manage the energy storage component of air conditioning across an entire city for load balancing and regulation. And therefore, air conditioning will be free to the user because the value of the battery side is higher than the capital cost of the unit.
Would a
So
city ever
that's
figure
the
that
ultimate.
out?
Ah,
Would a city ever figure that out?
oh yeah, yeah, that's happening. So already the utilities around the United States and around the globe are looking at creating distributed energy resources, having what is called non-wires alternative projects, which are projects in which it is less expensive for the ratepayer for someone to do something on the other side of the meter than to do it than for the utility to have to do it. Let's make the case here. We're in South Florida, right? Um, in South Florida, we need to put, and the plan is to put an enormous amount of new battery capacity in order to stabilize the grid, and and um, um, and drive. Ultimately, the goal is to have higher reliability, and also reduce the cost of electricity for everyone. But that's very difficult because land is expensive. And if you're going to put a battery system, you need to be able to acquire land. And so you need to negotiate for that. There's not in my backyardism, so NIMBYism. You need to go through an interconnection queue to make sure that whatever you're doing is safe for all the utilities around you and for the entire transmission distribution of electricity in the nation. And you have to worry about fires because batteries are flammable. And so you are a utility, you have to put gigawatt levels of energy storage in a city, let's say down here in Miami or in South Florida, and you don't have access to land. You need new interconnection points, you need controls. So it's a very expensive and uncertain project. It would be so much easier to just give people air conditioners that eliminate 60% of the peak load on the fly when you need it. And in doing so, eliminate the need for those batteries. And and that will have two effects. One, the margin on the electricity that they're selling to the consumer now increases because it's now tied to lowest cost of electricity production, which tends to be renewables. And secondarily, it reduces the ratepayer's cost anyway, because now that infrastructure doesn't have to be put into the rate for everyone.
Do you see other companies, the traditional air conditioning companies, as they were, moving to this kind of approach, or just staying with what they have?
So Carrier just recently announced that they are planning to put batteries on residential air conditioners. And so tying those things together with the goal of providing that like peak load elimination and finding new capacity for these units, and also making them a little bit more efficient in the way that they operate by leveraging time of use of
Is that
when
a
you
different
consume
approach to the
electricity.
same thing, kind of?
So the issue is that they're using batteries. So a battery will increase the amount of electricity that you consume in reality because you put one amount of electricity in, you get less than that on the other side. Um, and then batteries still are much more expensive than my stuff. And also they're flammable. So you have to worry about where you place them, and you end up with flammability concerns
Why don't they do what you're doing?
because they don't have access to that technology. So the technology is actually way different than what they have, and my technology is unique to me. And we have 42 patents associated
Those
with the
patents is the
technology.
bottom line.
Yeah, yeah. So patents and know-how and
So,
investment
so would you license it to others eventually?
eventually, I think that that's going to happen. So we are, um, the mission of the company is to make air conditioning become a solution for sustainability and health of people, um, and making air conditioning highly accessible. And the only way that we can do it, I mean, this is one of the largest markets in the world, and it's a global market, will be to make it accessible to others. And but the value of that license won't be valued such that we can achieve our mission unless the technology is proven out and is threatening and enabling, right? And that threatening and enabling side is important. Threatening in that um, if you don't adopt it, you'll be left behind. Um, and then enabling, if you adopt it first, you will leave the other behind, right? And so we have those characteristics in our technology, and there's a lot of opportunity to partner.
Well, I look forward to watching the space and watching what you do going down the road. Thank you, Daniel, and thank you all for listening to the voices of the Internet of Things. I'm Chuck Martin.
Such a pleasure. Thank you.